To determine whether a certain permutation sigma is a cycle on a certain set, in this case S8, we need to establish the orbits first of this permutation, and with that we are going to use that idea in determining whether this permutation is a cycle or not, because a permutation sigma is only a cycle if it has at most means a maximum of one orbit containing more than one element. To start with, let's start with the orbits of this permutation sigma. Now we have a separate video already discussing the idea of, or the orbits of this given permutation sigma. You might want to check the separate video for that. But here, let's do it here as well, but in a shorter method. Let's have the orbit containing 1. When you have this, we will just see that 1 is being mapped to 3. Therefore, it will be like this. Since this value here is not the same as the first element, so we are going to continue with the use of that value here on the other side, or the element. So as we map 3, you will have here 5. Then we continue for 5, we will be having 2. Then let's have about 2. So 2 will go to 4. And then finally, I'm saying finally because if you are going to look at your permutation, 4 is being mapped to 1. So we just return to the first element that we have tried. Therefore, we could have this orbit here following this pattern: 1, 3, 5, 2, and 4. Now, of course, this orbit is a set. You can rearrange the elements, but this is in connection to a certain idea of cycle. Okay, because that's the goal here. We're going to determine whether this permutation sigma is a cycle, and if it's a cycle, then we are going to illustrate that cycle using a specific pattern. So why not try to start practicing a set like this? Nevertheless, this is just the same if you're going to rearrange it. Now, 1, 2, 3, 4, 5 are already done. Let's have the orbit containing 6. Since 6 is just mapped to 6, so we'll have that. So you have the orbit is a set containing 6. This is also true for your 7, because 7 is just mapped to 7, and your orbit is a set containing 7. How about for 8? As you can see here, 8 is also being mapped to 8. Therefore, your orbit is a set containing 8. So we have 4 orbits here. Our first orbit has 5 elements. Why we're talking about elements? Because the identification of a cycle pertains to the elements or number of elements in specific or in all orbits. This has 1 element. This also has 1 element, and this as well, 1 element. So we have 4 orbits, but their elements, or the length of their not yet the length, but the orbits, we have 5, 1, 1, and 1. How many orbits here have how many orbits have more than 1 element? We only have this here, okay? Because this is exactly 1, that's exactly 1, and exactly 1. So we can say here that we only have 1 orbit containing more than 1 element. Hence, it fits to the idea that this permutation sigma is a cycle, because again, a permutation sigma rather is a cycle if it has at most 1 orbit containing more than 1 element. And again, here we only have 1 orbit with 1 element. Then we can say now, let's have here yellow. So we can say here that our permutation sigma is cycle in S8, as this is established by the idea of only having 1 orbit containing more than 1 element. So this is now the result. Now, before we end this video, once we can determine that a certain permutation sigma is a cycle in S8, we can establish it in this notation. Okay, since this has this is the orbit with 5 elements or more than 1 element, so you have here 1, 3, 5, 2, and 4 in that exact order. That is why I mentioned earlier that even if the set and you can rearrange the elements, it pays off if we would just simply stick with the pattern or the order rather, so that if we could establish that a certain permutation sigma is a cycle, then our cycle will also follow that same pattern. Okay? Here, just like this one here. So this is how we denote a cycle of a notation for a permutation. And with this, you could see here that this is the idea of this is 1 is being mapped to 3, 3 is being mapped to 1, 5 is being mapped to 2, and 2 is being mapped to 4. And it will go around here since it's a cycle. 4 will be mapped to 1. As mentioned here, 1 to 3, 3 to 5, 5 to 2, 2 to 4, and then 4 to 1. But since it's a cycle in S8, it still has 6, 7, and 8. But for this specific cycle, since 6 in this permutation is just being mapped to 6, we don't need to write that here automatically. Understandably, all other elements that cannot be found in this cycle are just being mapped into them their cells. Thank you very much for watching.